So this video will discuss regression. So when we're talking about regression in Excel, we're looking at comparing quantities. In this case, we're going to compare height and weight. And normally we want our x value to be our independent variable and y to be our dependent variable. So first thing we'd have to do is highlight our data, whether it's in rows or columns, it doesn't matter. And we're going to go Insert, and we start with a scatter plot. So if I come here to scatter, I can just choose the very first option there. And that's for we can come here to design and we can change our layout if we want. The first layout will give us the ability to label our axes. If we go to layout number 9, it does give us a lot more information, including the regression equation and the r-squared value, the coefficient of determination. So you can always use that, but I'm going to show you how you can go from just the standard graph. So I wouldn't want to have the legend, so I delete the legend out. And I can always change the size of my major and minor axes if I wanted by coming in here and doing formatting the axis. And here I can change that maximum, the minimum, and even the units. So maybe I want to do every 20 instead. And you can see how it shifts everything. But the big thing I want to do is actually look at the idea of understanding what's the trend line. How's this data looking? How's it compare? So if I right click on the data and I go to Add Trend Line, and what you'll see here on the right hand side are all sorts of options for what that trend line could be, whether that's exponential, linear, logarithmic, a polynomial, a power function. You can change those things, but at the bottom several things that can be helpful. One is to display the equation and to display the r-squared. And as I said, that r-squared is the coefficient of determination, and so that's telling us how much of the variance in the model comes from the actual trend line. Whereas when we start talking about linear models, we want to really look at the correlation coefficient. That's what's going to tell us the strength and direction of our correlation. But you can only do that with linear models. And you see here when we talk about correlations, we have that what makes a weak, a moderate, and a strong correlation. And if we see here, that's r-squared, and this is the linear equation, and I could always change it to exponential, and you can see that you get a little bit stronger r-squared. The power function gives a little bit stronger r-squared, but it's not like in this type, but it's a little bit higher value. And I can even change that to see what happens. But we're going to stick with linear, so I'm going to talk about the idea of correlations. So if I want to talk about a correlation, it has to be a linear relationship. I have to use the linear function. And here I see that r-squared is 0.7018, 7,108 10,000ths. And if I want to know what the r value is, I would just take the square root of that. And so you have 0.7108, and I get that it's about 84 hundredths, which makes it a strong correlation. Now, if I want to get the exact value, Excel does allow me to do that. I can do equals, and I do equals correl for correlation, and I would select my x values, comma, select my y values, and hit enter. And you can see how close those are, and that this is just rounded to the 5th decimal place, whereas this goes on much further. If I dragged it out, I can see that it continues to get larger and larger as I go on. So again, I can see that's a strong correlation, and if something were to change in one of these values, say that someone's 192 pounds, say they gained 20 pounds, and then went up to 112 pounds. I'm sorry, 212 pounds. You can see that that makes a stronger correlation, that it follows that relationship a little bit stronger. So it's important to see how does our data, if there's also outliers within that data that may be pertinent to what's going on. Hence why you have the line actually being drawn in so you can see how it relates to those dots.